Hey guys, how you doing? I hope you are good. My name is Enzo. I'm a teacher major in chemistry and biology and I focus on K-12 education. I make this series of videos to help you guys do some self-study and review what you've learned at school. Because the coronavirus is spreading all over the world these days. So I think a lot of you guys have to stay at home. But sometimes studying at home will be kind of difficult. So I do hope this series of video will help you a lot. And by the end of this video, just leave me a message. If you have any questions, problems you are struggling with, you can just leave it down there and I'm going to reply you once I see it. Also, please do not hesitate to like it and to share it with your friends, hopefully to help more students. Okay, we're going to start with VCE Chemistry 1, Chapter 1. This is the very beginning of the whole subject. Chapter 1's topic is the atomic nature of matter. It essentially tells us a lot of basic knowledge you're going to need to know about the atoms, which is the very, very fundamental structure of substances. So, to make it simple, atoms are just the basic unit of substances. Of course, the series definition will be much longer than this, but we just make it simple and make it straightforward to you guys. Cool. So here's a concise content about the whole chapter. We have 7 sections here. The first is nanomaterials and nanoparticles. It's all about the nano concept. What is nano? Section 1 tells us. Of course, in the following sections, we're going to go through the atomic world, such as the atom's structure. Is there any smaller unit in atoms? Of course, we do have. And then, how do the electrons in atoms are arranged? The last one is the Schrödinger model of the atom. It sounds a little bit complex, but if you can stick with this series of video, just leave your questions below this video. I'm going to help you through it. So today our topic is the first one, nanomaterials and nanoparticles. I'm going to give you a glance at the whole section. To make it straightforward, I list the 8 important points to remember. If you can master all of them, I think you won't have a lot of issues in this section. Let's start with the A. What are nanomaterials? Basically, nanomaterials are materials of nanoscale features. So, such features can determine materials' attributes. The nanoscale features are making the materials performing much more differently compared with the normal materials. The second one is, what is nanoscale? Nanoscale means 1 to 100 nanometers. Within this range, we are all talking about nanomaterials, nanoparticles, nano stuff, etc., etc. One thing important here is it actually can be longer than 1 nanometer. As long as it's smaller than 100 nanometer, that's okay. It's still a nanoscale material. For example, in daily life, you're going to hear advertisements saying that Intel computer chips are actually manufactured with the 18 nanometer standard. That's about the nanoscale. And what is 1 nanometer? How long is it? Actually, it's 10 to the minus 9 meter. This is one thing important, because you're going to need it when converting units. We're going to handle such kind of examples later. Be cool with it? Next one is special property. In general, like what I said, nanomaterials are behaving quite differently from ordinary materials. So they do have some quite unusual physical, chemical, and even optical attributes. For example, the nanoparticles of gold not showing us the color of gold. Actually, it could be different colors depending on the size of the gold particles. Because different sizes of the particles can reflect different frequencies of light into our eyes, so that we are seeing the color of different wavelengths. That's why different sizes of the particles of gold can give us different colors. We're applying this point to make some colored glasses. Let's go to the fourth point. How to make them, nanomaterials. There are actually 2 ways. All you need to know is just the general idea of them, but not exactly how to do it step by step. That's not the focus of this chapter. So here I'm just going to tell you, first is the bottom-up method, which is actually from something small to something big. Here we're starting with the nanoparticles, very small stuff, and then linking them together to form something big, bigger. And then it's actually the size of the material we want. But it's also nanoscale material because its basic structure can be very tiny. This is the first method. Then what is the second one? Can you guys have a guess? It is actually the opposite method, which is the top-down method, from something big to something small. It's like I've got an ordinary size of material. It's kind of big compared with the nanoscale. And then, in order to get some nanoparticles, I have to make it much smaller. For example, I can halve this piece of material and then keep continuing half it, so that its size will be much smaller. And then finally, I can make it within the nanoscale. So that's the top-down method. You guys just need to know the name of them. We've already conquered half of the main points, and then here are the second half. The E point is large surface area to volume ratio. It is actually telling us the surface area compared with the volume. The next point is the use of nanoparticles. With all of the above points being said, what's the use of nanoparticles? If we are manufacturing the nanoparticles, will there be anything benefit to us by using them? Of course we do. First one is the adsorption of molecules. We can use such kind of nanoparticles to adsorb some molecules we don't want. Please pay attention. Here we are saying adsorb, not absorb. You guys remember the difference between them? Adsorb is to attract the molecules you don't want onto the surface of the nanoparticles. But adsorb is actually containing molecules you don't want inside the nanoparticles. So the first one is on the surface, and the second one is within the nanoparticles. A good example of it is to use some activated charcoal to get rid of some unwanted gases, such as methanol from the air. And the second use is the transportation of molecules. We're using nanoparticles as a kind of shipping tool. Thanks to their big surface area to volume ratio, we can transport a lot of molecules. A detailed example is drug delivery in human body. We know that chemotherapy is actually injecting some medicine into human body and trying to let such kind of medicine to attack the cancer cells. But what if such kind of medicine are transported to the wrong place, to somewhere healthy? So the normal cells are attacked together with the cancer cells, which is unwanted. So with such kind of nanoparticles, we can direct the medicine, transporting them to the right place, so that we're going to have a better chance fighting against the cancers. Then we come to the third one, catalysts for chemical reactions. Being porous, the catalysts can supply a lot of surface area to the reactants, so that they can react on the surface of catalysts. That's all about the three uses of nanoparticles. And what we need to remember is they are all due to the huge surface area to volume ratio. G, safety concerns of nanoparticles. Why we're going to have such kind of concerns? Because they can actually transport tiny particles via air and leave them in human body. So this time, they're not doing the drug delivery, but something unwanted delivery. This is going to be a big concern. That's why we have the last point here. Humans' action against the concerns. We are addressing some regulations against the nanoparticles. Okay, so these are all of the main points we're going to master in this section. If you are still not clear about them, please go back and go through them once again. Then let's go to the exercise part. I won't have a lot of questions here for you, but only something typical. The first one is unit conversion. It is a common type of question you're gonna see in exams in quiz everywhere. If we want to convert a value from cm to nanometer, what are we gonna do? The first thing is to convert this value from cm to meter, because meter is the standard unit. and then we can convert it further from meter to nanometer. Here, both of the nanometer, centimeter are linking to meter. So meter is an intermediate stop we can use. Now I'm converting the value 12.49 centimeter to meter. And the next step is to convert the meter value to nanometer value. Nanometer equals to 10 to the minus 9 meter. So here I'm converting it backwards from meter to nanometer. Lastly, I can combine these numerical items as my final result here. Please do remember to use scientific notation because this number here is very huge. So this is the unit conversion. It's a typical kind of question you're going to meet everywhere. Let's go to the second one. The diameter of a basketball is about 24 centimeter. Well, the size of a virus is 80 nanometer. So here I need to make a comparison between them. How many times larger is the former than the latter? This is like what we just solved. Let's do it. The first thing is still using meter as an intermediate unit, connecting both of the centimeter and nanometer. I'm doing some conversion here. Diameter of basketball equals to 24 multiplied by 10 to the minus 2 meter. And then I further converting the meter to nanometer like this, combining them. So here I finish the unit conversion. Now both of the sizes are of meter, which are uniform. And then I can find the times, which is here. Also remember to use scientific notation. So let's go to the next question, which is also the most important one. Calculating surface area, volume, and then the surface area to volume ratio. I have three shapes here, cylinder, cube, and sphere, and I need you guys to calculate them. The main difference between them are their individual shapes. These are something about mathematics. I won't say a lot about it because I think with the formulas listing here, you guys can easily come up with the numerical values. But I do have further questions. First one is, which shape's surface area to volume ratio is the largest and the smallest? You can easily pick them up, cubes and spheres. The second one is, please give an example when the large surface area to volume ratio is favorable. And also an example for the small surface area to volume ratio. Please do have a good think about it. Like what I said, a large surface area to volume ratio example is using the activated charcoal to absorb some unwanted gas from the air. But a small surface area to volume ratio, it is something interesting. What I can come up with is a kind of ridiculous condition. When you're making some chocolates, but you don't have enough package material. So that you're gonna save your package in order to wrap up all of the chocolate you just made. So in this case, what kind of shape you're gonna think about? Please take a look at this table. I'm gonna go with the sphere shape because of its surface area to volume ratio. Okay, if you do have more questions to ask, please leave me a message. I'm going to try my best to answer your questions. Please do not forget to like it, share it with your friends, and subscribe my channel. Thank you guys, good luck with your study, and I'm going to see you in my next video.